Hi everyone, in this video we're going to discuss our 10.1, which is involving maximum minimum point, critical point, point of inflection, and sketching the graph of the function given. So for here we have a function here which is x cubed minus 4x squared plus 4x. We're going to find out the critical point for the first part. So critical point only happen when f prime x equals to 0, which is our first derivative. When it equals to 0, then we only can find out what is your x value here. To differentiate our function, so power move to the front, power minus 1. So this is our first derivative. Make it equals to 0, and we need to find out what is our x here. So you can use your calculator to help you doing this factorization. So we have 2x critical value here, which is 2 over 3 and x equals to 2. After we get the x coordinate, the next one is we're going to find out what is the y coordinate. So to find the y coordinate, we will substitute back this coordinate x back to the original functions here. So from here, it will give us 2 over 3 cubed minus 4, 2 over 3 squared plus 4 times 2 over 3. Another coordinate here, we substitute value 2. Therefore, after we find our x value and y value, we put it in coordinate form. So 2 over 3, 32 over 27, and another coordinate 2, 0. They are critical point. Finish our first task. Second task, use find the relative extremum, means ask you to find out what is your maximum or minimum using first derivative test, meanwhile the third part is using second derivative test. So every time we get this critical point, then when you want to find maximum minimum, we need to do the test. For the second part of the question, they mentioned here, they ask us to use first derivative test. First derivative test is about tangent, gradient of the tangent. So we need to build out our table to identify our interval here. We have 2 points here. We need to identify the gradient of the tangent before this point and after this point, before this 2, 0, and after 2, 0. So therefore, we have 2 points. We will have 3 intervals. So in the middle here is our critical point where it is x equals to 2 over 3, interval less than 2 over 3. And another critical point is x equals to 2, means this is in between 2 over 3 until 2. Then after the critical point, more than 2. So we want to see before the point, after the point, before the point, after the point. Then later we pick a test value and we substitute into our f prime x to see the sign. Lastly, to get to the conclusion whether the tangent is going up or going down. So 2 over 3, we can pick the test value, let's say 0. In between 2 over 3 and 1, 2, we can pick 1. More than 2, I can pick 3. Substitute here, you can use your calculator to substitute that. When you have 0, 0, you get positive 4. This is positive. When you put in 1, I can see this is 3 minus 8, negative 5, plus 4 is negative. But you can use your calculator. If I put 3 here, 3 square, I get value positive. So conclusion here about our first derivative test is about the status of the gradient, status of the tangent. So positive means the gradient is going up. Negative means your tangent is going down. Positive means your gradient of the tangent is going up. So when you have tangent going up, meet your point in the middle and the tangent going down, and we can observe here actually 2 over 3 and 32 over 27 is in the situation of maximum, because we can see going up and then going down. So this is your maximum point in the middle. And another point here, 2, 0, we can see before 2, 0 going down and then after 2, 0 going up. This is the case of minimum point. So as you can see, the tangent going down and then pass through the point, critical point, then the tangent going up again. So this is a minimum point. After the test, we can classify it. Then we continue for the third part. They are asking us find the relative extremum point by using second derivative test. So from here we can compare. If using first derivative test, the working will be like this. If I want to use second derivative test, it's about concavity. What's mean by concavity means your graph senyum ataupun masam. Concave upward, concave downward. First of all, we need our second derivative. Differentiate one more time. It gives us power moved to the front, power minus 1 minus 8. So we have 2 points to test here. For the x equals to 2 over 3, we just need to substitute into the second derivative test and we show it the working. So 4 minus 8, negative 4. Negative 4 indicate that it is less than 0, which means this is concave downward. So when you have a concavity downward, we know that the point of 2, 3, and 3 over 32 over 27 is in the case of maximum. So we can conclude here it is maximum point. Another point we need to test here is another critical point here, which is x equals to 2. We substitute into our second derivative, which is 6 times 2 minus 8. You will notice here we get positive value. So positive value, it will be concave upward. When you have concave upward, which means that this value will give you in the situation of having minimum. Therefore, we can finish our classification here, where the point 2, 0 is minimum point. Then we continue for the question number 4 here. Find out the point of inflection. So when we have first derivative, we notice that we have 2 critical points, and these 2 critical points, after undergo the test, we manage to classify these 2 points, what is maximum, what is minimum, which means that from first derivative test here, we no longer can find any inflection point, because all these critical points already classified to maximum, to and minimum. So in order for us to find the inflection point, we can find from second derivative, let it equals to 0. So second derivative, we already differentiate, which is 6x minus 8. We let it into 0. So this x can give you another point here, which is equals to 4 over 3. So when I have x equals to 4 over 3, I find out the y coordinate. Y coordinate, we need to substitute into the original function. Cube minus 4x squared plus 4x Alright, so when you want to find coordinate, we substitute back to the original function. Find out the coordinate y here. Therefore, the coordinate that we get here, they might be inflection point. So to confirm that is it an inflection point, we still need to undergo the test. So the test that we can do for inflection point normally is second derivative test, but it's not substitute this value. Second derivative test, see do in table, seeing before the point and after the point got changes of concavity. So to test inflection point, now we start back for second derivative test, where interval, when we only have one point, which means that I only have two intervals, x equals to 4 over 3, we will take x less than 4 over 3 and x more than 4 over 3. From here, I will pick a test value so that I can test it, my second derivative, sign whether positive and negative. Then I want to see the conclusion, whether it have changing in concavity. If we have changing in concavity like this, so which means that the point that we check in the middle is inflection. So this is concave upward, this is concave downward. Or if you have concave downward first, this is concave downward, then concave upward. So this also is inflection point. Alright, so we find a test value here less than 4 over 3. We can put 1 more than 4 over 3. I can put 1.5. When I substitute into second derivative here, 6 minus 8, I know this is negative. Negative in second derivative, which means that this is concave downward. And when I put 1.5 into the second derivative here, I get positive. So you can press your calculator, 6 times 1.5 minus 8. Yeah, you get positive 1. So positive means concave upward. So you see it have a changing. It concave downward. Then after that, pass through your point and concave outward. So now we can definitely do the conclusion. 4 over 3, 16 over 27. It is a inflection point. Then lastly, for our question, in the task number 5, we're going to sketch out this graph. So we use all these maximum minimum point, we plot it, and we will going to sketch it. So first of all, label your x-axis and label your y-axis. Now we start to plot in your point one by one. You have maximum point happen at 2 over 3 and positive coordinate. So I take this one 32 as 27. So this is maximum point. And minimum point happen at 2 over 3, 3 over 3. So happen at 2, 0 here. This is your minimum point. And differential point happen in the middle, 4 over 3 with the coordinate 16. So 16 over 27 is half from like 32. So this is my inflection point. So our graph, it tends to touch the y-axis. Means I need to find out what is y-intercept. Let x equals to 0. Put in our function here, x equals to 0. You'll notice that it equals 0. So 0, 0 is your intersection point here. 0 intersection point. So with all of the point plotted here, now we can start drawing. So you will know that from here, read your result here, from here, before 4 over 3, it means before this point, it is a case of situation of concave downward. So do a concave downward at least, concave downward. And after 4 over 3, it is concave upward. Your minimum touch value 2. So this is concave upward. Therefore, you can see the whole graph is curving like this, and this is what? This is your cubic function. So your cubic function is in the S shape. Yes, it is correct. So let me draw it better. Touch your minimum point. Alright, so this is the concave upward, with this is maximum point, and this is concave downward with maximum point. This is concave upward with minimum point at 2. So join the dot. After we plotting all these points, so label your point. This is maximum point that I calculated just now, 3 over 2 over 3, 32 over 27. So plot it, label it. This is 0, 0, intersection. Inflection here, 4 over 3, 16 over 27. Minimum here, 2, 0. Label all these points that you find. And lastly, label your graph with your function name here is x cubed minus 4x squared plus 4x. So function here is equals to x cubed, then minus 4x squared plus 4x. Alright, so that's all for this question. Thank you for watching.